Dear students, grade 11, this is the third video to study about aldehydes and ketones. This is the third part. Again, let's take a look at the learning outcomes. In the first two parts, we studied how to name each of aldehydes and ketones. We learned about the functional groups, their general formula, and we also learn about the formation of aldehydes and ketones by oxidizing primary and secondary alcohol. In this video, we will start learning about the reduction of aldehydes and ketones using NaBH or 4 or LiAlH4, and the reaction of aldehydes and ketones with cyanide ion, whether it's hydrogen cyanide or sodium cyanide. Okay, first of all, aldehydes and ketones reduction reactions. Let's ask ourselves one question. How aldehydes and ketones reduced using the cyanide ions? As we have seen in the learning outcomes, we said that aldehydes and ketones can be reduced by three elements. One of them is cyanide ions, so the cyanide ions, we have two types of compounds that can reduce aldehydes and ketones. That's hydrogen cyanide and NaCN. Okay? So let's take a look at the equation using the HCN or the NaCN. Okay, what is that compound's name? Okay, we said we start counting from here, so this is 1, 2, so, and it's CHO, so this is an aldehyde, right? So 2 carbons and aldehydes, this makes it ethanol, right? Ethanol plus HCN gives that compound. What is that compound? So you have an OH and you have also cyanide ion. So reacting the aldehyde with HCN or NaCN, both of them are the same. Here's what happens. Here, so it's CH3, it's the same, and CH, OH, and CN. Now, CH3, CH3, this is actually ketone. So 1, 2, 3, this is propanone. And since it's as 2, so it's 2-propanone. Again, when it's reacting with HCN, all you have to do, this is the carbon, you add the H, there is an H, and there is CN, same thing, and the CH3. So when you're reacting aldehyde or ketone, okay, you add, there is an O here, so you add O, there is an H, and then CN. Here is the same, you have, there is no H here, but in ketone, CO, then you add the H and CN. Look at the resemblance, it's the same. Of course, this goes for hydrogen cyanide or sodium cyanide, it's the same. All we need is the H and CN. Okay, another way to reduce aldehydes and ketones is using NaBH4 or LiAlH4 ions. Okay, in this compound or that compound, we're reducing agents, and both of them can only be represented by hydrogen. Reducing agents means they add hydrogens, right? So we can only represent them by H, You don't have to write the whole name of the compound, you just write H. So again, this is ethanol. When you reduce it by either this compound or that compound, so again, instead of writing just this compound, which is sodium tetrahydrodoparate, this one, NABH4, this is called sodium tetrahydrodoparate. Or we can use LiAlH4, and this is lithium aluminium tetrahydride. Okay, instead of writing these compounds, you only write H. So again, ethanol, when you write H, it turns to, this is what? This is an alcohol. And what type of alcohol? It's primary alcohol, because the carbon attached to the OH has 2 hydrogen. Okay, now we have to learn about the mechanism for the reaction between the cyanide, hydrogen cyanide here, and aldehydes and ketones. Okay, so first we will study the reaction with aldehydes, the mechanism of reaction with aldehydes. This reaction is called a nucleophilic addition. Again, let's remember, what do we mean by a nucleophile? A nucleophile is a chemical species that is negative, and they call it a proton acceptor, right? Or electron donor, correct? So the mechanism here, for example, we're having ethanol here, 2 carbons and CHO, so this is ethanol. This is the CN, which is our nucleophile. So as I always said to you, the nucleophile, which is the electron donor, they always attack. Okay, so the CN, or the cyanide ion, attacks the carbon, the functional group, which is CHO. Okay, so CHO, here's the carbon attaching to the oxygen with a double bond. So in here we have two covalent bonds. So the CN attacks that carbon, okay, and then when it attacks the carbon, this bond will break. Okay, so this bond will break. So it's attacking this one. Remember when we studied that in alkenes? Okay, usually here is a big density of electrons. So cyanide, when it's reacting this big density, because here you have 4 electrons just between the oxygen and carbon. So because this is also negative, so it's repelling the electrons, and only the partial negative or partial positive charge is found at the carbon. So the carbon becomes partially positive, and all the electrons headed away from the negative ion, so the oxygen becomes partially negative. Okay, and then one of these bonds, which is the easiest one, remember what is the name of the easiest bond to break? Which is pi bond. The pi bond break because you're having an addition. An addition happens when you have a double bond, a double covalent bond. So the pi bond breaks, and the CN is connected to the carbon. Still, the oxygen have too much electrons, because actually it is higher in electronegativity than carbon. And then this what happens. Remember, this is the negative ion, and here comes the positive ion, the hydrogen. So the hydrogen, here we have the oxygen, which is now more dense, and we said the more dense always attacks. So it attacks the hydrogen, and here. So again, the cyanide, the nucleophile, attacks the carbon because here we have large density of electrons. And since there is electronegativity difference between the carbon and oxygen, So in this case, when the cyanide, which is negative, attacks the carbon, the electrons are repelled and they headed away from the negative charge. So the carbon becomes partially positive and the oxygen becomes partially negative. Then we have an intermediate. This is called an intermediate. The cyanide attached to the carbon after breaking the pi bond. The oxygen becomes highly negative, and then you have it's attached to the hydrogen from the HCN. This is the positive and this is the negative ion, and then we have the final result. Okay, so this is the key. So the bond between the carbon and hydrogen is broken. The pi bond is broken. The oxygen attached to hydrogen and the carbon attached to the cyanide ion. This is for aldehydes. Now for ketones. Okay, we have here an example. This is propanone. Okay. In the first stage, again, it's the same thing. The cyanide attacks the carbon where there is high density of electrons, correct? So again, the cyanide attacks the carbon, the electrons heads to the oxygen away from the negative ion. So the carbon carries positive, partially positive charge, and the oxygen becomes partially negative. Next step, the double bond or the pi bond breaks and the CN is attaching to the carbon. And then the hydrogen again attached to the oxygen. And there you have it. So it's CH3 and the C with the O and then the H and the CN. So in the first stage, the nucleophile attacked the cyanide ion on slightly positive carbon atom. The negative ion formed picks up the hydrogen ion from somewhere, of course from here, the radical. For example, the hydrogen from the cyanide molecule, another molecule. This was our lesson for today, and stay well. Hope to see you soon.